All right, so let's take a look at our lesson for today. We're going to look at implicit differentiation, day 2. And what we're going to be working on today is actually a second derivative using implicit differentiation. There's a few extra steps that we have to do, so I made this on a day all by itself so that we could really focus on it and make sure we understand how to do that. So we're going to start it out just like we would, we know to get to the second derivative, we have to find the first derivative before that. So we're going to do that first, just like we did, I guess we did this lesson on Monday. So let's go ahead and just do, regular. Remember, it's with respect to x. This tells us which variable to differentiate with respect to. And so this one has an x, so I would just say 8x. I wouldn't need to tag it because it is an x. We are differentiating with respect to x. And so the next one we would say minus 4y, and now since this is not an x, we have to tag this one. So it would be dy dx, and then the derivative of 9 would be 0. Now we're going to go ahead and solve for dy dx just like we would previously. It's just going to help our case. So let's go ahead and solve. So I would move the 8x over. I would divide by the negative 4y, and I would come up with dy dx equals 2x over y. Now, let me point out here that it would really be to your advantage to simplify, instead of leaving it at 8/4, to simplify it. We have some problems on the daily work where it's possible to simplify and students aren't doing that, and it makes the second part of the work much more difficult. So just keep that in mind. If you're able to simplify the coefficients, if you can factor a 2 out, and just if you can, you should, because it will make your life easier for the next part of this venture. So what we need to do now is to actually find the second derivative, and we just like regular. What I'm going to do is I'm actually going to do the quotient rule instead of doing the product rule. You certainly could do the product rule if you want, but you'd have to be moving things to the numerator and then down, up and down. So I'm just going to leave it like this and do the quotient rule, which we remember would be fg minus fg, first things first, second things second, over g squared. All right, so that's what we're going to do. So the derivative of dy dx is simply d2y over dx2. Okay, pretty straightforward. Then on the right side, so the derivative of f, which would be the numerator, the derivative of 2x would be 2. Copy paste the denominator, minus they basically copy paste the numerator, and then multiply by the derivative of the denominator. So the derivative of y would be 1 dy dx, and then all over y squared. Okay, so we okay? Now here's where the new part comes in, what we haven't had to do before. It's kind of cool that we have a first derivative and a second derivative in the same equation. That's kind of cool. I'm not doing a derivative, I'm just doing a g squared. Yeah. So it's kind of fun to have a first and second derivative in the same equation, but we really can't leave it like that, right? We can't leave it like that. So we actually do know what the first derivative is. We found it. It's right here. So we're going to have to substitute it in. So let's do that. So d2y over dx2 equals 2y minus 2x, and I'm going to open up. I'm going to take the dy dx out, and I'm going to put in 2x over y, all over y squared. Now, we have a complex fraction. That's not okay. We know that we can't leave it as a complex fraction, so we're going to have a little bit of work to do, just like we've done with complex fractions for a very long time. We're going to find a common denominator in the numerator and get that together, and then flip, we're going to fix the complex fraction. Just a little bit of saving me a little bit of time, I'm going to go ahead and multiply these two together so that I don't have to do an extra step. So 2x times 2x would be 4x squared over y. I had a question earlier today about this. I hope we remember that this is basically over 1, right? And then we just multiply the numerators and denominators just to remind us that we can get, this gets kind of overwhelming and we forget just basic stuff. So that we would have 4x squared over y. So now the common denominator between these two would certainly be y. So let's just kind of move that up here. 2 d2y over dx2 equals. So this one, of course, would be over 1. So I need it to be over y. So it would be 2y squared over y minus 4x squared over y, all over y squared. Just to remind you, that's over 1. So we have 2y squared minus 4x squared over y times, and we take this little guy and flip him upside down, 1 over y squared. So d2y over dx2 equals 2y minus 4x squared over y cubed. Now we're really excited, we're really happy. Where are we? Oh, thank you. Okay, so we're really happy, we're really excited that we've gotten this far, and we're thinking that we're done. Now, I know, but something actually very cool happens a lot of the time, and you're thinking, how could this keep happening? But I would say probably 40 or 50% of the time, there is one more step that you need to do. I know, isn't that awesome? So what I want you to do is I want you to look at our second derivative. And I want you to look back at our original equation, and I want you to see if you can see anything that looks familiar. Isn't that so awesome? Okay, some of us have it. So I want you to look at this piece right here, and I want you to look at this piece right here. They are basically identical, except they're opposite. So I'll show you the formal steps. I would factor out a negative. So this, a negative, and then that would be negative 2y squared plus 4x squared. And then what is this guy going to turn into? It's going to turn into 9. Isn't that so awesome? It's like magic. I don't know. It's beautiful. So my actual derivative is negative 9 over y cubed. Now, it's really important because this would be a typical question they might ask you on the multiple choice. They like to ask questions that involve equations, find second derivatives or first derivatives or stuff. They certainly might ask you that, and they say, find the second derivative of this, and you are happy and you come up with this, but you don't see that as the answer choice because they would write it like this. So we have to learn to recognize when it's possible to back substitute. Oh no, I just wanted you to see exactly what I was doing because I did this problem earlier and there were some people that were confused on exactly what I did. So I just wanted you to see, how it really works, why it was a negative 9 and not a 9. I had some students confused as to that. I substituted. We found dy over dx. That is 2x over y, so I just substituted that in. You mean finding the third derivative or something? Oh, no. No. You mean as an answer choice on the test? No. They're going to give you the most simplified answer choice. They're not going to give you... I've never seen a question that asked you to choose simplification. No, they're going to simplify it. For the first derivative. Well, the first derivative normally, perhaps it's not typical, but that doesn't mean it's not possible. You would have to take the derivative of this and then look for any patterns. And I haven't done the third derivative. I don't know if there are any patterns in it or not. It might just be a big mess. I don't know. Okay? Yeah. So, shouldn't be a big issue. Yeah. Are we okay with that? All right. We have one more thing to look at. That's this problem right here. So, let me get us some space over here. All right. Okay. All right. So what this is in preparation for, we want to, it's actually for our related rates, which we're going to be starting tomorrow. And in the related rates problems, you're going to have to differentiate with respect to t. And t is rarely a variable in the equation. Now, sometimes there is a t in the equation, but normally there's not. Normally there's just other variables in the equation. So we're going to practice today on just that. How do you differentiate with respect to t? And that's all. We have related rates is a pretty important topic. We're going to spend 3 days working on it. And so we're going to prep that work by going through and showing how to take the derivative with respect to t. Okay, so first thing we want to look at is how many variables we have. We actually have 3 different variables, and none of them are t. Okay, so let's plan our work. If I look to the left side, that's going to be pretty straightforward, right? The derivative of v with respect to t would be dv dt, 1 dv dt, so that's pretty straightforward. On the right side, I have a little bit of an issue going on in that I have a product, right? I have a product. We have to really keep in mind that we've got to plan our work. What template are we going to use to put our derivative pieces into? On this right side, we're going to have to use the product rule. All right, so let's start. So we're going to take the derivative with respect to t. So the derivative of v would be 1 dv dt. Pretty straightforward. The 1/3 pi, I really don't want to mess with the constant right now, so I'm just going to put it on the outside and just kind of ignore it. I know it probably is upset about that, but I don't want to work with the constant. We're just going to leave it there. And so we're going to do the product rule, which is fg plus fg, first things first, second things second. All right, so let's start. We want to take the derivative of the first thing, which is r squared. The derivative of r squared would be 2r, and it's not a t, so we'd have to tag it dr dt. Okay? 2r. In related rates problems, we take the derivative with respect to time because they're word problems, and we are interested in rates over time. So that's what we're practicing. We're practicing taking the derivative with respect to t, which in the cases we're going to be doing is time. All right, so dr dt. So we took the derivative of f. Now we copy g, which is just an h, plus we copy down f, and then we take the derivative of g. The derivative of h would be 1 dh dt. And then we're done. We're not going to do any simplifying on this because tomorrow we'll do different things with it. But what I would like to talk to you about is look at how many rates are represented here. We have the rate that volume is changing with respect to time. We have the rate that the radius is changing with respect to time. And we have the rate that the height is changing with respect to time. So that's a lot of different rates. I hope that that would make sense to you. If we have a lot of different variables, we might want to see how we can eliminate a variable by maybe making it with respect to a different variable, So otherwise, we're going to have 3 different rates to deal with. Okay? So in this case, we're pretty much done. We're learning how to take the derivative with respect to t, and we're not going to do anything. We're just going to do that, and then we're going to stop. Don't try to simplify. Don't try to do anything else. Just leave it as it is. So it's just practicing a technique that we're going to utilize tomorrow. Okay, any questions? Okay.